Tá mutado.
Hello. Nice. Let's go.
Yeah,
Thank
now I
you.
can hear.
Yeah, I was. Anyways, hi guys. Good evening for all. Thanks for joining us today. I'm hosting today's Ubitalk, and we're gonna have a quick talk about delivering better quality code. Again, my name is Adewale. I work for Ubiminds right now. I've been working for Ubiminds for the last 3 years. I am a computer scientist with 8+/9+ years of experience. Entrepreneur. I've worked delivering high quality code for companies in multiple areas like education, accounting, tourism, health. I've worked with business intelligence too, a little bit, and I'm very interested in distributed computing and machine learning. If you guys want to reach me out, my handle is at Adewale Andrade. It's weird speaking my name in English. In most social media, and here's my email if you want to reach me out. For those of you who don't know me and you don't know how to pronounce my name, don't worry about it. I don't mind you trying it the wrong way. Nice. So what's this going to be about? I like to be forward with you in the sense that this is not going to be a highly technical talk. We're not going to dive deep into code and anything like that. My motivation for this is mostly frustration with collaboration along these years, not specifically this recent years, but I've been working with people that I assumed would deliver higher quality code, and that wasn't really the reality. And I'd like to discuss with you some ideas around quality code and what's the minimum we can do to make sure that we're delivering the best code we can do. So we're going to touch a little bit of what is software quality, what to keep in mind when you're trying to clean up your code, especially what to stay away from, how to make sure you're delivering code that is testable, how do we use our tools, make sure that we're using the best that we can, how to improve our skills, and I'm going to wrap up with some brief recommendations, and then we can maybe have a Q&A and discuss something. So starting with software quality, this can be kind of subjective, but shouldn't really be, because there is a ISO, which is a international standard that defines what should be expected from high quality code. And that ISO has around 8 pillars for what defines code quality. Not code quality. I mean software when I say code, because I work more with code on my day-to-day. So there are around 8 pillars that define high quality software in general. But as an engineer that's mostly coder, I highlighted these 5 aspects that we should always keep in mind. So first of all, we it's expected from us that our applications have good design. And this good design ranges from the user experience, the UX, the UI, the architecture chosen for the application, and the code itself. What are the design patterns? What is the domain, the schema that we apply to this? So this is obviously an obvious aspect to consider when we're trying to check the quality of an application or software. Another very important one is consistency. So, and this means how consistent, of course, the application is across platforms. So does it work? Is it multi-platform? Does it work properly on the web? Does it work properly in desktop? Does it work properly on the mobile applications and Android versus iOS? Is it the same experience across them all? So this is another important pillar that sometimes is hard to maintain, because usually when the application has multiple platforms for your small/medium company, you usually have multiple teams that are responsible for each platform. So there's usually a kind of a disconnect between, it's possible to have a kind of a disconnect between the teams on the different platforms. But yeah, this is definitely something to keep in mind. Also, you want the software itself to be durable, meaning that it shouldn't break easily. And even if it breaks, which obviously happens, how much downtime you have, right? So you don't want software that is breaking a lot or it breaks for a long time. Also, we want reliability. We want the experience and the overall response of the functionality of the application to be consistent, usually fast. But if you can make it lightning fast, at least make it consistent. Don't give a page for the user that renders in a couple milliseconds once and then a minute. And finally, one aspect that is really important, especially for me, is maintainability. So how easy it is to give support on that. If we have a defect, if a bug happens, how easy can we fix? How easy can we identify that? And what if we have new feature requests? How easy it is to evolve that application? What if we change context? What if the application, the users are gonna scale a lot? So let's say we're gonna have 5x users in the next couple of months. How easy it is to make it still work or do what needs to be changed for us to accommodate those that new flow. So the new flow of users. So this should be nothing new in here, but again, it's something to always keep in mind when we're discussing software, even on our day-to-day meetings, whenever you have it, like daily, or you're doing an estimation for a ticket, you're doing tech design, we should always keep all of those aspects in mind. Cool. So on that note, let's move to what not to do. If you don't take anything from this talk, please take this new term with you. If you're not from Brazil, this is going to be a totally new thing, but if you're from Brazil, you probably heard of this. So Brazilians are a resourceful people. We kind of have very powerful imaginations, and we definitely complete the tasks and overcome challenges, but not always in the best way. So as you can see in this image, this person wanted to charter a lot of things, and there was only one outlet, and they did this magic here to kind of connect everything into the one place. But this is probably gonna lead into fire and possibly people getting hurt. So the main thing here is prioritizing the functionality, doing the thing over how to do the thing. So for those of you who never heard this word and it's only speak English, the way to pronounce this is gun plus B from B, DA from apartment, which should sound like and ha from Kamehameha if you are kind of a otaku. So it should be Gambiaha. And please don't. So diving deeper into Gambiaha, I went back to my years in college where I was introduced to this weird piece of something. So someone, I couldn't find any data on the person who created this and what was the contest, but someone decided to kind of create a manifesto of a methodology that sums up everything we shouldn't do, and it called it Extreme Go Horse. The manifesto has 22 axioms, so there are a bunch of stuff that isn't good there, but this 5 caught more of my attention, and unfortunately are something that I still see on engineers that should not be doing this. So like the first axiom is, if you had to think about it, if you thought about something, this is not XGH. So if you're working on anything, if you're working on code and you see a problem and you don't think at all and you just start coding before even thinking about how's this going to work, how's this going to affect anything, how's this going to affect my teammates, just anything. If you don't think about anything at all, you're doing something wrong. Please stop doing that. Take a breath, go grab some coffee, look at it again, read it again, just think a little bit. Another axiom about this is the more extreme go horsing you do, the more you're gonna do. So that's kind of obvious. If you're doing stuff without thinking, if you're not giving time and giving in work on the quality of your work, it's highly probable that you're gonna do more work on that. You're gonna miss something stupid. You're gonna possibly affect your clients and maybe do irreversible damage, which is the worst case scenario, but that all comes from not thinking and doing stuff in any way instead of planning and doing it right. The 9th axiom is very ironical. Is be authentic. Extreme go horse doesn't care about patterns. This obviously is wrong. So we have well-established design patterns, structural patterns. And if you're working with a team, you probably had a tech design or something that you should be following. But sometimes we still see the cowboy developer that thinks that he knows better and his idea should be the idea to go, even though there were patterns before. So again, please, let's not do this. Let's think and consider our patterns. Sorry, if it's working, don't mess with it. This is portraits of working with legacy code. I see this a lot, especially when you're working with large applications that have very old code that possibly no one on your team even saw it come to light. It's very common to see people only getting in and doing what they need to do, the minimal work, and not trying to touch anything else since it is working. Let's leave it there. Let's not try to improve the documentation. Let's not try to refactor this. Let's just leave it there because we kind of don't know what's there and it's working, so let's leave it there. Please, let's not do this. And finally, tester for the week. It should not surprise anyone why this is bad. We should be trying to deliver code that is trustworthy, and the best way to get there is through testing. So yeah, let's try to keep the bad stuff in mind to not do it. Thinking on that note, thinking about cleaning our code, my biggest reference is the book Clean Code from Robert Martin, which is a classic. And it's very big. I mean, depends on what you read. But anyways, it has a ton of information there. It's very detailed. And there are some things that I think are really high level but important things that we should keep in mind when developing software. So, for instance, whenever you're touching code, thinking about quickly identifying code smells and not ignoring them. So whenever you're touching code, you're developing yourself or you're maintaining that is super rigid or too complex, or it's something that looks like it's going to be hard to move if we needed to change it. Those are indications that the code should be refactored and that we should do better on that. And again, sometimes because of reasons that vary from specific context, we kind of tend to not pay as much attention to this. So basically, whenever we see very high level code smells, we should at least discuss with our teams and discuss with our teammates to schedule the possibility of refactoring this and if possible do it right away. So again, those okay, yeah. Let's move forward. I'm trying to outrun myself. So again, when we're developing functions, so going kind of deeper here, when you're developing functions methods, we want what identify a good piece of code, right? So first of all, the function we're trying to do solid snippets. So we want the function to be responsible for a single thing. It should be easy to read. It should be easy to test. It should be descriptive. Don't do more than one thing at a time. So all of that's going to make our code better, easier to maintain, and most of all, easier to test. So let's. So one thing that I see a lot is very common. When I first started reading about cleaner code and trying to use tools, for instance, I work more with PHP, and the tools that I use. So I can use like a PHP code snipper to verify rules like this. I can use it to automate alerts and warnings about how big my code is, how big my functions are, my methods are, how many methods I have in my class. And in theory, this is all easy and simple to do, right? So if you have a method that has 100 lines, of course you should refactor it and try to go to smaller methods. But depending on how you work, how your team is structured, how your company faces development, it's very common to see classes that have tens of methods, like 20 to 30 methods, and functions less methods that have hundreds of lines, but not touch them because they are working. So it's kind of extreme go horse. And in those environments, in theory, everyone knows that we should be striving to do more smaller functions and simpler code. So again, just just reminding, this is just me venting about simple stuff that I still don't see sometimes. Talking about code clarity and readability, I often discuss with my teammates the use of comments. There are people, I've seen very strong engineers, very experienced engineers that tend to really favor a lot of comments that I don't think are the best. And I'm not trying to wrap up discussion here and saying that my way is the best way or anything like that. But I really agree with Robert Martin here, where when he says that the least comments you need to put in your code, the better your code is. So your code should be self-explanatory. If you're writing code that need to be explained, it's very possible that you're writing bad code. Of course, there are some business logic that are complex and need better context, so that is easier to maintain. But that's not really what I'm talking about. I've seen a lot of code that have self-explanatory comments, and that is obviously a bad thing. So this is an example, like comments around you're recommending a variable and you say that you're doing that. So that's just noise on your code, and it may lead you to think that you're making things better, but in the end, you're just adding extra noise and make the life of other people harder. You're giving people more work. Yeah. And finally, when developing software, we should always be thinking about testing, automated testing. And I'm gonna go quickly over the test pyramid, but the idea is that we should try to focus more on cheaper tests. So we want tests that are fast, independent, durable, self-validating, and basically we need to focus more on unit tests versus integration tests. And when I say we, I say engineers in general. So yeah, just touching test pyramid concept. So the higher the level, basically, we want the tests in our application to kind of mirror pyramid in the sense that we should have more of the types of tests in the base and less of the types of tests in the top, because the top tests are more consuming. So from the top to bottom, start with unit testing that are should be the most simple and inexpensive tests, should test only a single component, a single functionality of that component, and should be really quick to set up, really quick to execute, and have no side effects or anything like that. And then as we move up, we start to test multiple elements. So instead of testing a unit, we are testing multiple units leading into each other. So we have component and integration tests that start to get more costly, but are still way cheaper than having someone manually testing something. More cheap and safer, since the human factor is kind of bad thing in multiple senses, multiple sense, in the fact that we can forget stuff. So basically, our code should be to try to deliver more high quality code. We should at least try as hard as we can to make sure our code is unit testable as much as possible. So we should have clear, concise methods and functions that are unit testable. Of course, you can't unit test everything because nothing works by itself. We're building stuff, but yeah, we should. I think we should exhaust the possibilities of having unit testable code before moving to higher levels of testing. And since I've talked about having more unit testable code, of course, I'm not even scratching the surface of any of these topics I've mentioned so far. But the idea is that my idea of this is have a quick reminder of the minimal we should do to make sure that our code is good. And when I think about testable code, there are two aspects that come to mind right away when I'm reviewing code and I want to check if the code is unit testable. And the two things are if the code has side effects and basically how much stuff that the method is doing, the function is doing. So, and those two things have simple solutions. So to solve side effects, usually we do dependency injection. So we leave the responsibility of setting any mutant thing that we have that snippet of code. We convert that into an argument, and that will make our logic more consistent and easier to test. And having smaller functions and methods that do only one thing, of course, will make things easier to test. So just to more quickly illustrate this, this is an example about, let's say you have a method that should parse to you what time of day is. So if it's between 12 p.m. to 6 a.m., 12 p.m. to 6 a.m. should be morning, 12 from noon to 6 p.m. afternoon, and all that. And you have this method where it's the method's responsibility to get the time. So it's not getting it as an argument. You could do a test that is consistent. So for instance, you could like do the setup in a way that you change the clock and make sure that the time is the time you want to test, so you don't have any side effects. Or you could do something that is heavily overused and misleading, which is mocking everything. So you could mock the fetching of the time and make sure that it is always responding with what you want. But the thing with mocking is that we basically, you're forcing a scenario, you're kind of getting a controlled false positive. And the more mocks you use to do a unit test, the less behavioral testing and more code implementation you're doing. So you tend to do a search on which line of code is used as called instead of the behavior itself. So that's not good. Like I mentioned, an easy way to solve issues with side effects is doing dependency injection. So instead of like fetching the data or doing an external call or doing a side effects inside your code, you convert it into an argument, which your method depends on, and everything is better. Everything is easier to do. So you can just do a simple test like this, where if you want to get the time, if you want to test if your method returns the proper time of the day label, you just pass in the specific hour you want to test, and it should be always consistent, and you have less code. Yeah. So we're talking about methodology and design patterns and best practices a little bit, very, very little. But another thing that I think helps a lot in trying to developing good quality code is using tools to help you. So since the possibilities are kind of endless, the more tools you have to enforce your best practices, the better. So I highly recommend to automate as much as you can. So in this automation, it can be a environmental automation, so like using Docker or having scripts to spin up your environment and all that, and provision and stuff, and that's good. But I mean, more in the day-to-day, so have pre-commit scripts that enforce that your static analysis is good, you verify your code is up to the patterns and the design that your team defined. And this is very simple to do. You can use linters, code sniffers, different languages have different tools, but most of them have those. It's just a matter of applying it. Most languages like PHP and JavaScript, TypeScript, and similar also have tools that will fix most things for you if it's possible. So for instance, PHP has the PHP beautifier, PHP code beautifier, which checks for sniffing errors, link errors, and if they are simple enough, they are automatically fixed. So that saves you time and headaches. But since we should not be super focused on specific technologies, I don't want to discuss specific tools. So I don't want to say that this IDE is good and that is bad. That's not what this is about. What it's about is whichever tool you use, make sure you're using it the best you can. So I've personally I've seen people kind of struggling a little bit when moving between different IDEs just because they are not used to it. But I mean, this is mostly a matter of taking a breather to do your documentation, do quick searches, and looking for tools to use. So whenever I change tools like IDEs or anything like that, I ask myself, am I using everything I can? Do I know the shortcuts? Because they can change between applications, of course. And what can this IDE automate for me so that I don't need to keep checking it manually? And again, of course, IDEs are very powerful. You can do lots of stuff. This is an example of one I currently use, which is PHP Storm, IntelliJ PHP Storm. And this is one of the multiple tools that the IDE has, which is live templates. So I can create custom code that is generated by simple shortcuts. The animation got too fast here, but basically I have a live template where if I need to create like a data provider for tests, I can just type DTP and it fills in the boilerplate for what I need to do. And stuff like this might seem silly, but considering the amount of times you do this during a single day, it ends up adding into more time that you can be thinking about hard stuff instead of losing time typing or doing silly things. So other tools also have things like this, but again, IntelliJ has a productivity guide, which is a tool that helps monitor how well you're using this tool. So if you're how often you use like shortcuts or autocompletes or even templates and stuff like that. So it's always good to check what is the equivalent of this on the idea of your choosing and let the tool help you do better. So yeah. Finally, I just wanted to talk a little bit about one of the ways that I think it's are good to keep improving your skills. Of course, it's very common for all of us to keep getting updated on new technology, new languages, new frameworks, new tools in general to be up to date. But sometimes I've seen lots of people, in me included, that end up not practicing problem solving as much. So I've used in the past a couple of tools to help on this. And there's Code Signal and Code Wars. Basically, these are platforms that gamify solving solving CS problems. So basically, you have a platform that gamify solving computer challenges. I'm sorry, I got distracted here. Code Signal, for instance, you have different roles where you can go through. You can solve domain-specific issues through company bots. So you can like have problems related to data structures. You can have problems related to scheduling. Sorry, I was trying to remember. You have bots that generate issues related to specific tools. Like you can see problems that are related to like Twitter or Sana, which is tools for task management and other tools. So, and you can also see other people's solutions, so you can compare your code to other people. You can view different solutions in different languages. So it's also a tool that helps you possibly transition to a different language. And yeah, there's also Code Wars is similar. It mostly varies on the paradigm where it focuses progress in the kind of karate dojo structure. So you can have teams that are your dojo, and your levels are queues. So you can kind of change bands, but they're basically the same. You have a repository of different challenges that match each level you are, and you can solve them in multiple languages. Sometimes problems have specific languages that you need to use, and you can have back-end issues, you can have front-end issues, you can have data science, data science challenges and all that. So there are really many options for you to keep testing your skills and improving on problem solving, not totally focus on specific language or specific technology. Yeah, I just wanted to wrap this up with 3 books recommendations. If you haven't read them, please do. The main book I recommend is Clean Code by Robert Martin. This is more focused on actual coding, so it's a more technical perspective on it. The Clean Coder focus more on the behavioral aspect of the programmer itself. So how you should behave when you're working with code, how you should behave, how you should deal with deadlines, how you should deal with collaborating with the team, making sure that the code everyone's writing is good, up to your standards, all that. And the pragmatic programmer is also a very good read. Although I feel like it's the most dense of them all, but yeah, it has a little bit about philosophy and a little bit about coding as well. But yeah, this is just some a few recommendations for that, and I think everyone should at least take a look on their careers. And yeah, that's it. Hope I didn't bore you. And let's discuss if you have some questions. We have some stuff in the chat. Yeah.
Very shy today. Rodrigo, do you have anything that you'd like to comment?
No, from my side, I think very good the speech you gave. One thing that I'd like to add, for example, when you're talking about the tests, you emphasize it a lot on the unit testing, you know, and one thing that from a front-end perspective, one thing that people usually is a good pattern, for example, is that people are trying to focus more on the integration tests nowadays because, you know, you spend a lot of time unit testing it, but I think that when you make integration tests, you cover the whole application and you reach case that you'd never reach when you're just doing unit testing, you know. So I see that both are important, but I don't know if this test pyramid is what people should actually be focusing on. So just a question.
No,
What do you think about that?
Sense. It makes sense. So the reason I think we should focus more on unit tests is that because they should be simple, small, and very fast to run. Ideally, you should be able to like run unit tests on any code change you do. Any if you change a single line of the code and you commit it, you could automatically run all the unit tests for that. You could also do that for integration tests, but since integration tests usually, like you said, try to go through specific use cases, so it will move through database requests, sometimes API requests, so we'll try to load components and then stuff. So it takes more time than unit tests. So like you should be able to run a unit test suite like in less than a minute.
Yeah.
Ideally, but integration tests take way more. So think if you want to test all the time, it's less practical to do that with integration tests.
Yeah, I totally agree. I think that when you're doing unit testing, when you're developing, thinking about unit testing, makes your code looks better from the beginning, because when, for example, just the fact that you need to think that you test it makes in the dependency injection as a requirement for your code, for example. I totally agree, and I think that it's cheaper to write the unit testing, faster, and it serves well as documentation for other developers. And as you said, integration tests, I think that is what gives you the most reliability of your software, you know. But I totally agree, you have to mock everything, and it takes a considerable amount of time, and it's more expensive. So yeah, I agree with you.
Yeah. Yeah, nice. I mean, another thing about unit tests is that, so like I mentioned, integration tests usually, not always, but usually they try to reflect use case, right? Use cases, right? So, but the use cases might not always cover all of your code. So like it will touch a bunch of functions, a bunch of methods, go through some ifs, some flows, but not everything, not the whole thing.
Yeah, that's true.
And for unit tests, the idea is that you want to test that specific block, but you want to cover all the possibilities. So you're gonna have edge cases that the user should never do. So you shouldn't have a use case for that specific edge case, but your unit test should cover it. So in a way that if you want to use that same unit of code to do anything else, that crazy scenario is already covered. So you don't need to worry about that. You're just gonna couple that, just gonna take it and use it. And for integration tests, it's not the same, right? You just want to make sure that it's actually working for the end user for that specific.
Yeah, I think that another great thing about integration is that you think more in terms of how the user should interact with your software, and not exactly prevent things that other developers would change in our code. For example, I think unit testing protects a lot to the code itself from other developers and from the engineering team. And when you think more, integration tests makes you think more in terms of the user interface, the user interaction with software. So from the front-end side, I think that's one pattern that people are trying to think in terms of software. There are different ways to approach this, but I think that is an interesting idea that maybe will work well for the back-end side as well. So that's it. Cool.
Nice.
I have a question.
I love that people. Oh, sorry.
Oh, sorry. So do you have ideas on how to incentivize people to write cleaner code? Because I mean, tooling will only get you so far, right? I mean, tooling is amazing. I've worked in repos without style checkers and all those things, and it's kind of annoying to keep repeating the same comments. Oh, so you missed space here, add a new line here, and so on and so forth. But tooling will only get you so far, right? There are a lot of smells that they're not able to capture. So, and we will also have to comment the same thing multiple times from time to time, right? The same smells we see over and over again, and we have to keep repeating those things. So do you have any ideas on how to incentivize people to, from the get-go, write cleaner code instead of waiting on our feedback, right? Oh, so just keep the single responsibility principle here, so this and this will happen, right? Because if you wait until the problem surface, there will be like months from now, like to actually see the problem that surfaced from that smell that some developer left. sorry, yeah, that's the question. Like ideas on incentivizing
Yeah.
people to write from the get-go, write cleaner code. Yeah.
Yeah, no, good question. It totally makes sense. So I have two ideas, but one of those is that I don't totally agree on the limit of tooling. Well, let's set this splitter. So first, one idea that I think could reduce the churn on verifying code styles and code smells, like not leave it for every code reviewer in a PR to do that all the time and repeatedly. Is having shared or like synchronous code review sessions where the whole team is looking to the same code and we are at the same time discussing it. So we kind of raise the issue once and it's more evident for everyone. I've had experiences with that where that led to way less repeated comments in PRs than like only asynchronous code reviews. And yeah, like documented, if the company has the culture of documenting processes, that helps as well. But it kind of makes the issue depend on the engineer that is adding the bad smell as well. So it depends on the person going through the documentation and reading that and keeping that in mind. And I can argue that if the person does that, he or she is not probably gonna add code smells into it though. So yeah, it's tricky for sure. But going back to tooling, of course, tools have limits, right? So it can't cover everything, but especially on PHP, which is the language that I use the most, the head space on there is very large. You have well-established patterns. So in my experience, using the tools are usually way more restrictive than I've ever seen in code reviews. So I can, depending on how you set up your checks, the style checker can be very annoying on how many static analysis, right? So how many lines your methods have, how you're doing architectural erosion and stuff like that. But what I found is the hardest stuff on using this is making it customizable to your company's needs. So every group has different culture, every group has different preferences. Not everyone follows the same standards across companies. So in some cases, it's kind of hard to have flexible rules, but we can always decide to implement tools, right? So automation is about that. You don't, there's stuff that you do repeatedly that you take some time, write some code, and don't worry about that again. And sometimes, from my experience, we tend to not give as much value to this issue of automating the checks as much as we can, because it can be hard. Some problems are not that easy to solve. Yeah, I think tools are way more powerful than we give credit to them. But I'm not sure it's your case. But yeah.
No, I think that makes sense. I added this as a comment in the chat. You mentioned doing like sync reviews. That's an interesting idea. We do have retros as well. Like every 15 days we meet and discuss how the last sprint was. And so one other thing that could potentially work kind of similar to the syncing session on the pull request would be if you found a smell in a code, an interesting thing that you might find valuable, you could surface that smell to the sync meeting, like in the retro meeting, and then the broader group would learn like why that's a smell, how that was solved, and so everyone would know better next time, I think.
Yeah, that makes sense. The only concern I would have on this is that since you're trying to retros should be like light meetings, right? You don't want to be pointing fingers or anything. So, and for that to be effective, ideally you would pull up the code and go through it and point to specific things that happen. And I feel like maybe retros are not the best meeting for that because you're gonna end up saying, hey, this person did this that was wrong. And let's not do this thing that this person did. that can be risky, right? So
yeah, that's a good point. I feel like I think we at least in the company that I work, it's the same that Adewale works, I think. We have like a strong culture of not pointing fingers, and I feel like we do have that risk. Even then, I think you're right. Like we do have that risk, even though I think we do have a good job at making sure that we know that we're all together. It's not for us. It's never personal and all those things. And we use our language in a different way to make sure we don't point fingers to a specific person. Because I agree with you. Like it would be bad if we were like, oh, so you see, like Adewale did that thing. Do not be like Adewale. Let's do better. No, yeah, I agree. But I think there are still ways, and I mean, in a pull request that happens already, right? Like the people that are reviewing it are seeing that. And if we were doing like the synchronous pull request, they would know who wrote that code, and we would be like, okay, so do not do this, right? And so the issue still remains that you have to be careful with your language, not to say like you were bad because you wrote this, but like everyone is learning about a lot of things. So I don't even know how to recognize all these nulls on my code. And I'm pretty sure like I've written comments in every single person in my team, like comments in their pull request. So everyone's learning all the time, but I understand that it's a risk that should be considered, definitely.
Yeah, totally. Yeah, my only final 2 cents on this is that the context matter, right? So, for instance, retros, we define that retros should be a safe space where there's not going to be judgment involved and stuff like that. But everyone knows that code review is all about that. We're looking at what you're doing and we're pointing stuff. So I feel like people are prepared differently for those things. But yeah, I totally agree with you that communicating in a clear and non-violent way, and violent in the sense that you're not judging or making anyone uncomfortable, is very tricky and super important on this. Yeah. Awesome. Anyone else?
I think that was,
Do we have
I
time?
think that was really, really. I think we can stretch. Yeah, if you guys have time, let's do our extra 5 minutes for one last question, and then we're good.
Okay, we were talking about testing. And do you think that's realistic to aim for 100% test coverage for unit test? Or is there any situation where we should have a minimum amount of, I don't know, 80%, 90%?
Nice, awesome question. So yeah, I personally don't think that 100% unit test is even possible because your no code is 100% a unit. So unless your entire code base is just a single function, yeah, you can have 100% coverage. But on real life, where you have components, anyway, you're dealing with complex applications, you're not going to have 100% unit test coverage. But you can structure your code and structure your application in a way where you make sure that a section of the code needs to be 100% covered. So for instance, you can specify that all your business logic. So depending on the architectural pattern that your application uses, you can do different things. So let's say you're using a BLL architecture where you just have like an MVC/BLL. So you have controllers, business logic layers, and data access layer. And on your business logic, you have pure functions, which are functions that don't have any side effect, don't do any data fetch, don't check databases or anything. They're just functions that can be unit tested. But at the same time, you have your access on other BLLs or stuff like that. That is going to be hard for you to have 100% coverage, but you could like switch to a different pattern where you define that the class can only have pure functions. So you can have your BLL with only pure functions. You can't have your BLL calling any other methods and any other components, and that can be 100% tested. And you can have a different class that only does the integrating. So you're gonna have another type of class that you know that's only integration testable. And that is possible. And on the company I work, you guys know, on my team, we do this. So we have sections of the code and we have enforcers for that. We have linters, we have pre-commit scripts that check that. Whenever we add some code to that section, that needs to be 100% covered, and other parts maybe not. And on the other parts that are not, it comes to the team, the reviewers, to point out and check that we are testing enough. Yeah.
Nice, thanks. Very insightful.
Yeah, nice, great question. Cool, I think this is it, right? Thank you guys so much. Got really happy with the questions. I thought no one would have anything to discuss. So thank you very much for this. And yeah, Sheila, the floor is yours.
No, I was just going to say thank you very much. I think it's really good. Again, you brought a lot of technical insight. You can see people are engaged. And yes, thank you again. And honestly, you're didactic. Like, I don't know if you're a teacher before, a professor, but that was really good. Even like us from outside the field, we could learn a lot there. And thank you. And everybody, I'll see you next week. I have a call with Felipe Duarte as well. So exciting things will come. Okay, bye-bye.
Thanks, guys. Take care. Bye-bye.
Bye.
Bye.